Hello everyone, my name is Shagodamitse from Department of Electrical Engineering. Today I am going to present my final report on the course of fiber optic sensors. My presentation contents are like homework 1, homework 2, and homework 3. The first one is it is deal about homework 1. It is about fiber optic sensor for structural health monitoring. Here, let me discuss about why we use this fiber optic sensor for this application. Because these fiber optic sensors they are small in size, they are great variety measurable parameters, they are used in distributed and measurable topologies, they are insensitive to external perturbations, they are reliable in damaging environments, they are long distance remote monitoring and compatible with data transmission network. Due to this reason, we prefer this fiber optic sensor for the structural health monitoring activities. These are the parameters of the fiber optic sensor. We may give as measurable parameters like strain, deformation, force, temperature, chemical concentration, acceleration, rotations, electric field, currents, and the like are the measurable parameter of this fiber optic sensor. As general, fiber optic sensor may be classified into 4 different groups like point sensor, distributed sensor, long base sensor, and multiplexed sensor. These are the 4 classification of fiber optic sensor. Let us see one by one. The first one is point sensor or Fabry product sensor. They are known as point sensor for strain, deformation, pressure, temperature. They are very important for this activity because we may use this for long-term stability, high resolution, small size, and the likes. The second one is the working principle of this, what you call it, point sensor. This point sensor, the measurement principle of this is based on the cavity. So we create a gap between two fibers that are close to each other, and then we send the light from the fiber, and some of the lights will be reflected into, as you have observed here, some of the light will be reflected by the first mirror and part of the light will be reflected by the second mirror. We use instruments to measure precisely the distance between these two faces of the fiber. And we may apply this fiber like point sensor for measuring strain, as we observe here. We may use for measuring temperature. If we apply temperature, these two different the distance will be shifted, and we can easily make measurements. And we may apply also this point sensor for pressure and displacement as well. Generally, this point sensor has different application, different advantages like high resolution and accuracy, absolute measurement, temperature sensitive. But the challenge is multiplexing is the great challenge of this point sensor interferometers. Generally, we can install a point sensor as we have observed here. There is fiber for this take up, and there is sand pockets. Therefore, we can install this fiber optics as we have observed here. We may install these sensors in every aspect of the places. Here is data acquisition. How can we gather data by using these point sensors? Therefore, as we have observed, this data acquisition here is fiber optic uses piezometers that can be measured to very high speed, and so in this case they were interested to see during earthquakes how the poor water pressure will be react to the earthquake. And so we have some of the sensors that are connected to this speed and data acquisition system. They are triggered by the strong motion sensor. Therefore, it is very important using this data acquisition in this point sensor. The second one is multiplexed sensor, that you call it. The main example of this multiplexed sensor is this FPG, fiber Bragg rating sensor. As the best example, they are used to measuring this temperature, strain, monitoring based on this activity. They have measured strain up to 5. We can up to 5 to 25. The sensor will be used for this measurement of this what you call it temperature, and also the Gaussian length will be 10 centimeter to 2 meters. Therefore, it is very important to using this FPG sensor, and they are used for both static and dynamic environment and permanent. The permanent and remote monitoring will be with Ethernet, via Ethernet. It is how we perform this FPG, what you call it, fiber Bragg tracking. Therefore, this FPG, the measurement principle it is slightly different from what we have observed in the point sensor, because it is slightly different. Instead of having a gap between the two fiber, we now have the grating written into the core of the optical fiber, grating to a kind of periodic change density that we have right using the ultraviolet light, and this element is acting like optical fiber. So we send light with different colors into the optical fiber. Most of this color will be passed through the grating without being affected. Look here, we can use these colors, and most of the time we have observed this. The yellow color will be the reflective wavelength, depends on the strain and temperature of the fiber will be displayed. And this is the system component of this FPG. As we have observed here, we have sensor here, we have reading unit here, and this sensor will may be implemented in strain and temperature, and they may be in water right, insensitive to the temperature, easy and rapid install will be. We may use this for the system components of this FPG. FPG generally has this basic advantages. They have these basic advantages. They are but the challenges, temperature compensation, accurate and stable demodulation are very challenging using this FPG. The third one is SOFO technology or SOFO system. They are differ from the previous one. It is because it is used for long gauge fiber optic deformation sensor, and it is used up to 2 micrometer long term stability. They are the best application of this SOFO system, and they are used for advanced data management system. SOFO has these advantages. They are long gauge, high resolution, and accuracy, absolute measurement, and temperature sensitive. That's the advantage of SOFO. But the challenge is this dynamic measurement is the great challenges of SOFO technology. Look here, the sensor installation in SOFO. We can install, as we have observed here, we can easily install this SOFO technology in long distances. This is a distributed sensing application area. As we have observed, we may apply this different areas like buildings, land, tunnel, dam, river, and airplane. We may use this sensor because it has very variety application areas, and we may benefit from this distributed sensing like temperature monitoring, numerous points, and multiple point sensor will be implemented for this activity. These are some advantages of this distributed temperature system. Here is the optical scattering in silica fiber. As you have observed here, we have for long distance, we have to use this. We have used Raman, both Raman and beryllium. They are very important for long distance and distributed environments. Therefore, here in the distributed environment, as we have observed here, there is distributed sensor will be like Raman as well as beryllium are very important sensors. They may be used in long distance. The sensor has different cables. For example, we may use strain sensing temperature cable, these are some types of cables that are used in strain as well as in temperature in distributed environment. For among that, for the distributed environment, beryllium is one of the sensor types. It has advantages because it is used for distributed measurements, temperature and strain sensitive, but it is challenges, high complexity, demodulation. Distributed strain sensing cables are very challenging. Beryllium. Let me go to my second homework that is about, it is related topic about hybrid structural monitoring on composite plate manufactured with automatic fiber placement, including embedded fiber bragrating and bonded piezoelectric patches. Here is a motivation. There is, as you have observed here, there is a motivation why we use this SH hybrid structural hybrid monitoring. Why? It is, as you have observed, it is the motivation. Why? Because in the principle, the substrate monitoring system are able to reduce the percentage operative costs for airlines, as you have observed here. It is around 3 up to 4% will be decreased, because using this SHM system, we can skip some of the inspections that must be done on the aircraft that are visual inspection, like level 1 and level 2. Therefore, because of this, we may reduce downtime. Due to that, it is very important using this SHM for this activity as well. Therefore, as general, these are very important in order to downtime reductions that allows obtain the ultimate goals. And this is as well, it is diagram, it is about it is FA. It is FA, meaning most of the time this FA is very important in order to measure this SHA. As we observe, it is a hybrid system, because this preparation of this fatigue test is on the aircraft as general aviation. It is on the general aviation, and these aircraft are allowing reading composite carbon design proxy, and this part it is required to the fatigue that will be conducted with damage inside the structure, and it is very important using this in SHM construction. In this SHM construction, let me go to why we use this hybrid SHM. Why? What is the reason behind that using this hybrid? Okay, why we use this hybrid? Because in general we are interested into types of investigation, as you have observed here, that is event sensing and damage localization. Because when you say this event sensing, we mean that it may cause critical conditions that be detected in real time, allow that operator decide what to do, and damage localization, usually it is tolerant to structure damage, do not be localized at the early stage, but it is monitored to before and after the critical time. For that purpose, it is very important having this hybrid structure as monitor for event sensing based on acoustic emission, damage localization based on guided waves, PZT and FBG embedded secondary bounded sensor are very important. This is a sample description of FPG sensor embedded panel. As you observe, there are around 6 FPGs. As you look here, FPG, different FPG1, FPG2, FPG3, FPG4, FPG5, and FPG6. They are embedded here, but functionally 4 of them are functionally, but 2 of them are damaged while constructing this, implementing real times in the real times. It is a propagation panel, how we implemented this for FPG. And here is how we install this 6 FPG on the positioned on a PZDTE. And it is also a interrogator, this FPG interrogator descriptions, how these 4 different FPG gathering channel acoustic emission sensor interrogator are explained as well observe here. Different parameters are stated. The last one is my homework. Sorry, it is regarding about sensing there's crystal deformation with fiber optic. It is similar to the previous two homeworks because it focus on about this structural monitoring. Structural monitoring. Why we apply this fiber optic sensor for structural monitoring? Because it is structural monitoring. It is the application, one of the application area of this fiber optic sensor as well. There are different fiber optic sensor, optical sensor, maybe the main point sensor, multiplexer sensor, and distributed sensors. That's what I have said, what I explained in the first homework of my presentations. Here is, as well, it is known that the biggest structure on the Earth is the Earth itself. Therefore, here is it is the diagram depicts that how sensing the Earth with fiber optics looks like, and here is how we sensing the Earth with fiber optics looks like. That is acquiring dynamic information on the strain field around the critical faults and reveal the mechanism of seismognetic process will be expressed here. And also it shows about how we monitor and record the crystal deformation field by using multi-location measurement covering the fault. That is using this sensor network. It indicates the conventional sensor for geophysics. As we have observed, there are different conventional, but it is problem. It is big size and high cost. It is a problem to implement this. And why we prefer for this activity this optical fiber sensor? Because optical fiber sensor they are lightweight and small size. They are easy to install, strong against chemical, work with harsh environment, remote multiplex sensing, sensor network. These are the basic feature of this optical fiber sensor that we are implementing in this activity, what we call it SHM, like structural health monitoring system. The reason behind is this is that here is also it is quasi-static strain sensing. This is what it looks like as you have observed. Is the state of it is regarding about strain resolution how to it is dynamic sensor up to pico strain, and it is micro strain. By using this, it is small, but it's very important while we are using this quasi-static strain sensing. But the difficulty is quasi-sensing. It is because it is external is necessary, and elimination of ambient interference, large measurement range are required. This is very difficult. And FPG static strain sensor, it is as we have observed, it is FPG for static strain sensing. As we have observed here, there are different here, like we have used coupler, circulator, photo detector to implement this. And here is the FPG versus resonator sensors. As well, there is FPG and there is resonator, and we have implement for this scenario principle of integration. Here is the principle of integration. The principle is, as we have observed, there is spectrum of FPG and the spectrum of FPG ringing. It looks like here, as we have observed, the other and system configuration. There is system configuration. The system configuration just looks like as well. That is the stir configuration. We have implemented this function generator, coupler, circulator, phase modulation, and intensity modulation. It is the Riziki Research Institute in University of Tokyo in Japan, as we have observed here. Let me finalize my conclusion. I have concluded all of my three homeworks like this. The first one is many fiber optic sensor technology exists and have different types of application. Fiber optic sensors are novel, but well-proven technology useful for structural and geotechnical monitoring and instrumentation. The impact of detection techniques has been applied successfully on automatic fiber placement panel using embedded FPGA. A system improvement is currently in progress in order to increase the reliability of FPGA integrator when used to sense wave generators. An ultra-high resolution optical fiber strength sensor developed for the crystal deformation measurement. These uh, fiber optic sensors are great potential for crystal deformation measurement due to its advantage like high resolution, high speed, small size, and low costs. This is a reference of my homework 1, homework 2, and homework 3. Thank you very much for your attention. Thank you.